Today I'm here to talk about Chapter 4, producing data, collecting samples, and performing experiments. You already know what to do with data once you have it, but what are the proper techniques to go out into the real world and collect data on your own? There's many ways to do this, and I'm going to give you different types of ways to collect data. And throughout the process of these notes, I'll try to go as slow as I can, but if I go too fast, feel free to hit pause or rewind as needed. In order to gather information about a large group, I need to take a small sample that represents that large group. It may not be feasible to ask every single person within a group a specific question. So I think it's preferable to just ask a few selected individuals that represent the entire group. I then can gather some observations based on that small sample. One type of sample I could take would be a voluntary response sample. This is basically having people coming up to you and choosing to be part of your survey or your study. The problem with this is it tends to overrepresent people with their strong opinions. You get extremely high opinionated people for a product or extremely high opinionated people against a product. For example, if you've ever bought something online, you might read the reviews about it. And you'll see there's a lot of highs and lows. Either everybody's really for the product or everybody's against the product. It seems that people that only have these strong opinions are the ones that tend to want to take the time to write in something on the internet. This may also happen during a sample. I would say that two variables, whether they're explanatory or lurking, are confounded when their effects on a response variable can't be distinguished from each other. For example, back in 1940, there was a psychologist that created a test to find out the attitudes of Americans towards Germany. So he asked them a series of questions and sat them down through a bunch of different survey questions, and he gathered some data. Over the next few months, he then showed those Americans a bunch of German propaganda. He wanted to see if their attitudes would change over the course of those few months. Well, unfortunately for him, Germany attacked France and conquered France during that time, and he was not able to determine whether their attitudes have changed because of the war or because of the propaganda that he had shown them. So we would say that his variables were confounded. Statistical inference is going to provide some way to answer those types of questions with a guarantee that they are good answers. I have a population of people that I will take a small sample from. And the design of my sample refers to the methods that I use to choose that sample from the entire population. One type of sample is a convenient sample. I simply go up to the individuals that's the easiest to reach. If I'm a student in a high school, it might just be simple to walk up to the cafeteria. I would say the design of my study is biased if systematically favors certain outcomes. Let me talk a minute about random digits. There's a table in your book with a list of random digits, which are a simple list of random numbers. Every entry in the table is equally likely to occur. The digits will be the numbers 0 through 9. All entries are independent of each other. When I say independent, choosing one number has no influence on what the next number may or may not be. You'll see in your text that the random digits in your book are actually grouped in blocks of 5. The only reason they do that is just to make it easier on your eyes so the numbers don't run together. We'll be dealing with random digits a lot when we get to experiments. So let's choose a simple random sample with the acronym SRS. You're going to assign every numerical label to an individual in the population. Use the table in your book, start selecting numbers at random that correspond For instance, if I have 30 students in a classroom and I want to collect 5 students' quiz scores, I could give every student in the class a number from 1 to 30, use the random number generator to select the first 5 numbers that would correspond to the 5 people I would be selecting. Probability samples give each member of the population a known chance greater than 0 to be selected. If I were teaching 2 classes of the same topic, for instance, I teach 2 calculus classes, I could select 5 students from each class and then use those 10 total students to make some observations regarding the entire group. You'll see this happening a lot with election districts. You break them down into groups of similar people. Generally, people who live in the same area tend to have the same opinions. People that live in the city tend to all feel the same way regarding issues, and people that live out in the country tend to have the same viewpoint on different issues. So I could select a certain percentage from urban, suburban, and rural, and then bring those together to make a full sample. Here's your definition of a stratified random sample. Let me take a second to talk about a multi-stage cluster sample, another technique used for gathering data. I will take a sample from the 3,000 counties in the U.S. Let's suppose Montgomery County comes up as one of those selected counties. I will then select a sample of townships within each of the counties chosen. Perhaps Damascus and Germantown both come up. From there, I would select a sample of blocks within each chosen township. For instance, I could take a specific neighborhood from one of the many neighborhoods in Damascus. I could then sample several households within that neighborhood. This would be a multi-stage cluster sample. I keep breaking it down to an area where I can sample 5 to 10 households maybe from one neighborhood versus doing 5 to 10 households where I'm bouncing around the entire country. This helps my researchers spend their time effectively. They don't have to fly back and forth across the country. I can send one researcher to one specific cluster within the country and they can gather all the data, and I can send another researcher to a different cluster. Some cautions about sample surveys, or surveys in general. If I'm only sampling households, I'm going to miss anyone who is not living in a house. This would include people in college, people that are homeless, anyone that may be in jail. These people's opinions count, but if I'm only collecting information from households, I'm missing these people. If I'm doing phone polls, well, nowadays most people do have a phone, but there are certain few individuals that don't have phones, and I would be missing those people. If people only have cell phones, and I'm doing dialing household phones, I'm going to be missing those people. I don't want to selectively or intentionally miss people from my survey. A non-response is when a person refuses to cooperate. If I'm a surveyor and I'm doing a telephone poll and I call to a house and the person just hangs up on me, that's considered non-response. These tend to be higher in urban areas. Undercoverage. Purposely leaving people out of a sample. We could also have response bias. You have to be careful with the way you ask your questions, or you don't produce an undesired outcome. You want a person's true opinion. You need to ask your questions in a way that does not happen. A Likert scale is something I'm sure all of you have seen. You generally see these on sample surveys where they say things like, how do you feel about a certain opinion? Please circle the following numbers 1 through 5, where they give you a scale. A lot of times you'll see the neutral in part of the scale. I think this may be a bad idea because it gives people an easy out. You want to force a person to make a decision. If you leave neutral off, they either have to agree or disagree with a certain topic. It's too easy to make a person not think and just select neutral. And that pretty much wraps it up for the first part of Chapter 4. Anything else you needed to catch, feel free to rewind or watch this video again if I went too fast through any of the slides. See ya!